Module 1, Lesson 3, Graphs of Exponential Functions. I can classify a function as an exponential function, and I can graph an exponential function using a table. Open your workbook to page 15. Okay, to start off our lesson today, page 15, exponential functions, we're going to do a review real quick of yesterday's function, which was a quadratic function. The quadratic function was the U shape. So first of all, first thing we had to do is we used the numbers -2, -1, 0, 1, and 2, and we used those for all of our graphs yesterday. And then we subbed those numbers in to our equation. Negative numbers had to be in parentheses, except for when you're multiplying and then you want to use parentheses on all of them. So we did 3 times -2 squared minus 4, 3 times -1 squared minus 4, and we just keep replacing the x with the input numbers. 3 times 0 squared minus 4, 3 times 1 squared minus 4, and 3 times +2 squared minus 4. And remember, you should see a little bit of a pattern form when you do your y's. You're going to plug it into your calculator exactly the same way that we write underneath the word column. Which I don't have my calculator on the board turned on, so I'm just going to use my regular calculator. Actually, you know what? I'm going to turn it on because I know I'm going to need it for the problems that we're going to do later today on this lesson. So glad your calculator's going to take as long to turn on as mine does. There we go. Okay. Okay, so I did 3 times, you just type it all in exactly the way I wrote it down, times, and here's the negative key. A couple of you yesterday were hitting the minus key. -2 squared, now I use the minus key, minus 4. Enter. That one came out to 8. And then 3 times -1 squared minus 4. Enter. That one's -1. And then 3 times 0 squared minus 4. And that came out. So there's my first 3 answers, 8, -1, and -4. And then the next 2 should actually come out to -1 and 8. Let me just prove that to you. If I did my work correctly on the first 2 anyway. So 3 times 1 squared minus 4. Now, you really shouldn't assume that that's going to happen, because this is a good way of checking your work, and it did. And 3 times 2 squared minus 4, and there's my 8. Okay, so -1 and 8. So these 2 right here should come out to be the same, and these 2 right here should come out to be the same. If they don't, then you know you've done something wrong. And that was all because of the symmetry, which is what makes the U. This one in the middle is the vertex point. Okay, so I got 0, -2, -8. So -2 on the x, and +8 on the y. So going up. -1, so to the left -1, and then down -1. 0, so stay in the middle and go down 4. And now the next 2 points are going to be at the same level as the other 2 points, but on the opposite side of the vertex. So +1, -1, and 2, and +8. And there I get my U shape. Yeah. Okay, and that's what we learned about yesterday. Okay, going on to today's topic, I'm going to turn over to page 16, and the first thing we're going to do is we're going to watch this little video about bacteria doubling every second. So watch it. It's a quick video.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacteria, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
Okay, so starting that over again, notice what she says. Oops, it switched videos on me. Let me back up.
Bacteria reproduce very simply and rapidly by doubling their contents and splitting in two. Just one bacteria, dividing every 20 minutes, could produce nearly 5,000 billion bacteria in one day.
Okay, so she said that bacteria splits in two every 20 minutes, and in one day it can actually become 5 billion bacteria. I believe that's what exactly it said. Okay, so we're going to look at this population of a bacteria. It says graph a number of bacteria versus time in seconds. Begin by counting the number of bacteria present at each second and then plotting the appropriate numbers. Okay, so we're going to assume that this is taking place over seconds. So to start off, at 1 second, there's just going to be one bacteria. Oops. And then in 2 seconds, then it's going to double, so there will be 2 bacteria. In 3 seconds, so another second goes by, it's going to double, and there's going to be 4. And then in 4 seconds, it's going to double again, and there's going to be 8. 5 seconds, there'll be 10, it's going to double again, so there's going to be 16. And every time it splits, it doubles. So then there would be 32. And then we're going to graph the number of bacteria. So my y-axis is my seconds, and my x-axis is my seconds. This is my x-axis here. My y-axis is going to be my bacteria. And I got to go up to 32. Don't think if I count by twos that's going to work. 2, 4, 6, 8, 10, 12, 14, 16. No, that's not going to work. How about if I count by fours? 4, 8, 12, 16, 20, 24, 28, and 32. And then I'm going to plot my point. So the first point is 1, 1, which would be just a little bit above. Halfway would be 1, 2. So 1, 1 is just going to be about, a quarter of the way up. So it's just a little bit above 1. And then 2, 2, that would be halfway up, because 4 is all the way up to the next line. 3, 4. And then 4, 8. 5, 16. These points look like they're going to connect in a straight line. And then 6, 32. Okay, and the answer is no, that they aren't going to connect in a straight line, because you'll notice that each time that it's doubling, the points are getting further and further apart. Okay, so now what we're going to do is, actually in the video it said that they doubled every 20 minutes, not really every second. Even though in the video was actually shown in seconds. The video was 6 seconds long, if you noticed that. But in reality, they actually doubled every 20 minutes, it said. So we're going to show it doubling every 20 minutes now. So initially there was 1 bacteria, but in 20 seconds it would double, and there would be 2, and then it would be 4, and then 8, and then 16, and 32, and then 64. Okay, so now I gotta figure out how I'm gonna do my y-axis here. My y, sorry, not my x. And that's my bacteria, and I want to go up to 64. Let's see, would 8's work? Yeah, 8's would work. Instead of 8, 16, 32, 40, 48, 56, and then 64. Okay, so at 20, notice these are counting, the numbers that they labeled were 60, so that means that each of these are by 20. So this is actually 20, 40, 60, and then 80. This would be 100, and then 120. Okay, so at 20, there would actually be 2 bacteria present, which is just a little bit above. At 40, there's going to be 4 bacteria, which is halfway. At 60, there's 8. You know what's going to happen? The curve is going to actually end up looking exactly the same as the simulation in seconds. So at 80, there's going to be 16. At 100, 32. And at 120, it's at 64, which is the big jump all of a sudden. And it's going to keep going. And that's going to basically look the same as this curve right up here at 6 seconds. This is freezing on me. Oh. There we go. Okay, so that's what it would look like. Okay, these are called exponential curves, which we kind of talked about them in the last book. When we said not all graphs are linear, sometimes they're nonlinear. So we brought up actually the U shape. That one's nonlinear, it's a curve. And then this is another type of curve. It's called an exponential curve. And exponential curves, sometimes exponential curves go up, and sometimes exponential curves go down. And they look like this. So those are just 2 different ways that exponential curves look. Okay? So this one is increasing. This is an increasing exponential curve. And this is a decreasing exponential curve. Okay. Usually in real life situations, well, no, I'm not going to say that. I was going to say usually they're going to increase. A lot of times they're going to increase, but you can actually have a decreasing one. For example, if money sometimes decreases over time. Okay, so now we're going to go and we're going to do like we did yesterday, where we're going to do some input-output tables and plug some numbers in and make a graph. So we can see our exponential curves. Okay, so this time we're plugging into the exponent. Set a little higher. Let's see, we're going to use the same numbers we used yesterday on this one. So maybe plugging in -2, -1, 0, 1, and 2. That way we'll see both sides of the curve. And as far as our work goes, we're plugging into the exponent. So I'm going to say 5 raised to the negative 2 power, 5 raised to the negative 1 power, 5 raised to the 0 power, 5 raised to the first, and 5 raised to the second power. To raise something up, you use this key on your calculator. Okay, so I'll grab my calculator out and clear out my old work. So I'm going to say 5. And remember, my keys turn red when I punch them, so you'll know exactly which keys I'm using. And then here's the raised 2 key. And it puts a little box up in the air, and I'm going to put a negative 2. Make sure you use the negative sign and not the minus sign. Okay? Some of these are going to come out to be decimal answers, so I got 0.04, 5 raised to the negative 1 power, 5 raised to the 0 power, and I got 1. So those are my first 4 answers, 0.04, 0.2, and 1. 0.2 and 1. Okay, then I got 5 to the first power and 5 to the second power, 5 to the first power, and 5 raised to the second power, which are 5 and 25. Personally, I don't like that graph that's there, but I'll show you how you can work with it. Give me a second here. I'm looking at what kind of graph there is in the assignment. It's the same kind of graph in the assignment also. Okay, so what's going to happen on the assignment today is you're actually going to have to relabel your y-axis depending on the kinds of numbers that you get. Okay, so the x-axis is fine because you've got 1, 2, and you've got negative 1 and negative 2, but the y numbers, see like this one, the y, this goes all the way up to 25. And these grids here only go up to 10, so you're going to have to relabel them. And my recommendation would be to write the numbers on like the far right or far left of the graph, so that way you can see them clearly. Let's see, go to 25, when it really only goes up to 10. If I counted by 2s, that would go up to 20. How about I count by 5s? So for example, I'm going to count this one as 5, and then 10, 15, 20, 25. You can put it right here in the center. You can put your, sorry. You can put the numbers, here's what I'm trying to say. You can put the numbers right here next to those dots, but sometimes when you do that, you end up covering up part of what you want, where you want to graph, and then it makes it hard to see. So my suggestion is write it off to the side. Either way, it doesn't matter where you put the label. So my first point is negative 2 and 0.04. So that's over to the left, negative 2. 0.04 would be basically right above the x-axis. And then negative 1 and 0.2, that's going to also be practically right above the x-axis. It would just be a little higher. But these graphs are so little, it's hard to tell where it would be. And then 0, 1, since this first one is 5, that's just going to be a little higher than the last one. And then 1, 5, think about the shape that these are supposed to make. They're what we just made a minute ago. So that each one is climbing a little higher and a little higher. So all of a sudden at the end, it makes a big jump. So now here's where the big jump comes into play. 2 and 25. So that's a big jump. And then the shape of the graph, it looks like this. All of a sudden it jumps up really high. It's a big curve. And that's called an exponential graph. Okay, so that's our first example. Now they all look, how quickly they jump up, they're going to look a little different each one. Okay. So it just depends on what the numbers are that we're using. Okay, this one's 4 times 3 raised to the x power. Again, we're going to stick with these numbers, -2. -1, 0, 1, and 2. And then as far as my work goes, I'm going to say 4, 3, and then outside here, raised to the -2 power. And then 4, 3, raised to the -1 power. 4, 3, raised to the 0 power. 4, 3, raised to the first power. 4, 3, raised to the second power. These ones you won't see a pattern like yesterday's, but what you will see is that the numbers should steadily increase. All of a sudden get bigger and bigger and bigger. Unless it happens to be the opposite where they get smaller and smaller and smaller. And I'll give you a hint when that's going to happen. Okay, so 4, parentheses, 3, parentheses. And then now we use that arrow up key, so it gives us that little box up there for the exponent, -2. And that came out to 0.44. 4, parentheses, 3, raised to the -1 power. 1.33, so see how it's getting bigger? And then 4 times 0, and then raised, I made a mistake. What do I put in my parentheses? 3. So I need to back up here. This needs to be a 3. It's my power that's changing. So open that little box. That's where I need a 0. Okay, and that came out to 4. So I'm going to write these first 3 answers down. So 0.44, 1.33, and then 4. So there's my first ones, and they're getting bigger each time. Okay, going back to my calculator. 4 times 3 raised to the first power. And then, so it got bigger. And 4 times 3 raised to the second power. And it got even bigger. So 12, that's my big jump. 12 and 36. Okay, so this time my y-axis needs to go up to 36. I'm going to have my 4s this time. So 4, 8, 12, 16, 20, 24, 28, 32, and 36. I kind of looked at my numbers and I said, well, will all 4, 12, and 36 divide evenly into, or divide by 4, so that's why I decided to count my 4s. Okay, so -2 and 0.44, that's going to be just a little bit above the x-axis. And then 1.3, that's going to also be just a little bit above, a little higher than the last one. And then 0 and 4, so that's my first real jump up. 1 and 12. So 12 is the third dot up. And then 2 and 36, that's going to be the big jump. All the way to here. And there's our curve. Notice how when I make this curve, when I start the graph, I do not cross the x-axis. So, my magic pen's not there. Now I'm looking for something special. Oh, there it is. Okay. So right here, when I first start making the graph, I'm trying really hard not to actually cross the x-axis. Okay? Because those numbers there, that 0.44, they're really small, but they actually never go past 0. No matter how small those negative numbers get, they will not make the answer go to 0. So that's why I really try to stay really close to the x-axis, but I never actually cross through it. And then these numbers here, they're just going to keep getting higher and higher. Okay, that was example 3. Oh, look at example 4. Let's watch and see what's happening, what's different about it, other than the fact that there's a fraction there. Now, I told you guys yesterday when some of you were asking me for help on yesterday's one, and what do I do for a fraction? One way to use the fraction was to put it in your calculator as decimal, or put it in as divided by. So if you know what this decimal is, you can change it to a decimal, which I do. I know this one's 0.25. Okay, so 1/4 is equal to 0.25. So that would be one way that I can put that in my calculator, or I can use divided by. Okay, so again, inputs, I'm going to use -2, -1, 0, 1, and 2. Oh, somebody asked me yesterday on the lesson 2, do I have to put the x numbers in that order every time, -1? You don't have to, but if you don't, you won't see the pattern, like in this case, that the numbers keep increasing or decreasing, which we haven't seen yet. It'll just kind of look like the numbers are random if you don't all put them in order. Okay, so I'm going to use the 0.25 because I know that fraction. If you don't know that fraction, then you would want to put it in as 1 divided by 4. I'll show you that also. Okay, raised to the -2, 10 times 0.25, raised to the -1, 10 times 0.25, raised to the 0, 10 times 0.25, raised to the first, and 10 times 0.25, raised to the second. And those decimals are really important that you make sure you're using them. Let's grab my calculator. That's a 10 in front that my calculator is covering up. So 10 times 0.25 raised to the -2. And that one comes out to 160. Oh my gosh, that's a huge answer, 160. We'll talk about that in a second. So the other options, I said, were to put in 10 times 1 divided by 4, and then raised to the -2 power. So, and you come up with the same answer. So if you're not sure what the decimal is, just put it in as 1 divided by, or whatever the fraction is, put it in as division. Okay, so my next one is 10 times 0.25 raised to the -1 power, and 10 times 0.25 raised to the 0 power. Okay, so I got 160, 40, and 10. 160, 40, and 10. Do you see what's happening to the numbers this time? They are not increasing, but they are decreasing. Okay, next 2, I have 10. Oops. I forgot to go back to my pointer. Wrote on my calculator instead. 10 times 0.25 raised to the first power. And then 10 times 0.25 raised to the second power. Okay, and they keep getting smaller this time. So 2.5 and 0.625. So on this one, the answers decrease. And there is a reason for that, and I'll explain it in just a minute. Okay, so I have to go all the way up to 160, and I'm looking at those numbers, and I could count by tens 10, 40, and 160 all divisible by 10. Let's see, would that work? 10, 20, 30, 40, 50, 60, 80, 90, 100, 120, oh, that won't work. So my next option would be to count by 20s. So 20, 40, 60, 80, 100, 120, 140, 160. Okay, so my first number is -2 and 160, so that's right up here. -1 and 40. So there's that big jump. It's just backwards from what it was on the other ones. 0 and 10, so that would be halfway. And now the next two get lower and lower, so they're going to be really close to the x-axis. The curve is going the opposite way this time. This one's a decreasing curve. And it's not going to cross the x-axis on this side. Okay, so this one's a decreasing curve. I wonder if anybody's got any guesses as to why this one decreases and the other ones increase. Okay, I'll give you that hint now. The formula for these is y equals something times a number raised to the x power. And if the number inside being raised to the power, so if b is greater than 1, the curve increases. And on the other hand, if that number inside there is between 0 and 1, then it's going to decrease, like 1/4 was between 0 and 1. Okay, so it all depends on what this number in here is. Is it a big number or is it a tiny number? So if you look back at this one here, this is kind of a bigger number. It's bigger than 1, and that's why we had an increasing curve. This one, this would be the B number. The A number would have been just 1. So we had an increasing curve. Okay, and that's today's lesson. If you have questions when you're doing your assignment, make sure you ask for help.